Hi, in this lesson, I wanted to start to look at some of the evidence we have for human evolution. We're going to look a little bit at body fossils, but we're also going to consider some of the, if you like, the trace fossil evidence that we have for the development of humans up to and including our own species. So, let's start by just thinking about this. This is the quite incredible site of the Lascaux Caves in France. If you haven't done so already, it's worth taking the virtual tour of these to see the type of images um, painted at the height of the last glacial period on these cave walls. They really are quite remarkable, and it does beg the question: um, why these images are so important. What do they tell us about our ancestors? I'm going to leave that question hanging until later in the lesson. Meet your family. This is where we've come from, where we see the separation of progressively closer relations to our own species. I want us to have a look at some of the evidence for this. Okay, this is it's a cladogram. What evidence do we have for these different splits, particularly the splits that occur more towards the right on this diagram? You have a copy of this on this worksheet. This is the worksheet we need for today's lesson. We've got the cladogram on the left, and then we've got a whole series of characteristics shown at the top. What I'd like you to do as we work our way through this is to be ticking off the characteristics as they appear, and also some idea of the timescales involved. Okay, let's go. Let's start with Sivapithecus from about 12.2 million years ago. These are definitively apes. These are the probable ancestors of orangutans. If we look at the skulls of these two groups, the Sivapithecus and orangutan, we can see that there are some clear similarities. The frontal sinus, the position of the eye sockets, the very broad nose, and the teeth being really quite similar. So we can see that there's a clear relationship between these. If we compare that, say, with a chimpanzee, now a chimpanzee will show some similarities with humans, perhaps compared to orangutans. However, we didn't evolve from chimpanzees. We share a common ancestor, but we're not an evolutionary development from them. But which of these is going to be the closer relative to us? Orangutans or chimpanzees? When we start thinking about human fossils, we perhaps go back to the various species of Australopithecus. This includes perhaps the most famous human fossil, Lucy. Now, the Australopithecines existed between 5 and 1.2 million years ago in eastern Africa. And we do find a reasonably good fossil record of this group. If we compare chimpanzees with Australopithecus in the middle, with modern humans on the right, we can see that there are some links here. There are some shared features. And even just a quick glance at this, the diagrams of these skulls, really does indicate that Australopithecus is if you like, a missing link between the common ancestor that we share with chimpanzees and modern humans. If we look at the structure of jaws and teeth, for example, we can see this quite clearly. The chimpanzee jaw there has very simple teeth. Australopithecines, though, have teeth more similar to the human jaw. This is where we start to see this feature appearing. Also, if you look at the shape of the jaw, you can see it more resembles a human, perhaps, than the very narrow jaw of a chimpanzee. So these one-cusp teeth are a chimpanzee feature. The two-cusp teeth are a feature of modern humans and Australopithecus. If we look at the structure of the limbs, something those of you who would have done GCSE would have looked at already. If we look at the position of the pelvis and femur, the thigh bones, we can see that modern humans are adapted for an upright mode of life. Chimpanzees, not so much. Chimpanzees walk upright. They can walk upright, but it's quite awkward. Australopithecus, though, had that same pelvic and leg structure and thigh structure, the modern humans have. Clearly adapted for an upright mode of life. Their ankles as well, the angle that the feet can get, are far more adapted to a walking mode of life than chimpanzees, who can bend their feet to quite surprising angles, because that helps them climb trees. If we start then to look at some evolutionary developments then from Australopithecus, we have a species we call Homo habilis between 2 and 1.5 million years ago, again in Eastern Africa. We start to see some changes here. You can see they're much smaller than modern humans, more similar in size to Australopithecus. But if you look at this fairly simple diagram, we can see that the brain is perhaps growing. We're going to come back to this idea of brain growth a bit later on in the course. If we look at this on a graph, we can see that over time, the brains of hominid fossils have been growing in size, been growing in volume. Interestingly, this relationship between brain size and time changes with the evolution of Homo habilis. The growth becomes exponential. It becomes far, far more rapid after, or should I say, with Homo habilis than it's been earlier. This brain size, we think, is a key part of human evolution. Perhaps related to this is the fact that Homo habilis is the first species that's able to actually make tools. We can see from looking at modern chimpanzees, they'll use tools. They'll hit fruit with rocks, perhaps to break it open. But they don't make those tools. They don't shape or fashion the rocks that they use. The evidence suggests that Homo habilis was the first species to actually do this, to start to develop technology. If we move on in time again, we get to Homo erectus between 1.5 and 500,000 years ago. Notice how the geographical distribution of this species is starting to spread. Like their ancestors, they walked upright, they used tools, they had bigger brains still. But we see some other evidence as well. In China, there's a cave site with Homo erectus fossils, clearly somewhere where the species lived, and we find charcoal. And we find that in layers as well, along with charred bones, burnt stones. They were clearly using fire to cook, as a key part of their lives. As we move on in time again, to between about 300,000 and about 40,000 years ago, particularly in Europe and the Middle East, we find the Neanderthals. Now, Neanderthals, there's been a lot of work done on this group. They're not one of our direct ancestors. They and modern humans coexisted. There is DNA evidence to suggest there was interbreeding. There's even suggestions that Neanderthals would be able to walk around Cowbridge today and really not be noticed. The skull size, and with it the brain size, was very similar. There are some small differences in terms of the shape of the skull, particularly in terms of the very large brow ridge that Neanderthals would have had, and perhaps a face that was a little bit more projecting. Modern humans have a flatter face, smaller brow ridge. But really, these are quite subtle differences. We do find evidence that they're the first group to actually incorporate ceremonies. There's evidence of ritual in the way they treated their dead in particular. And that's where we're going to find most of the fossil evidence. The use of fire, the grave goods, the care with which they were laid out. Neanderthal dead weren't just thrown in a ditch. Which brings us to us. What makes us distinct? Language, symbols, art, logical thought, communication. Our earliest ancestors evolved about 400,000 years ago and have spread everywhere. So we should, by now, have a completed worksheet. We should see how these features have developed over time. We can see that Australopithecus is the first group to see the bicusp teeth, the upright walking. Homo habilis has the larger brain, the ability to make tools. Homo erectus mastered fire and was able to use fire. Neanderthals incorporated ceremonies, and modern humans have the symbols, the language, and the means of communication, a key part of our development. Which takes us back to Lascaux. I think these are so important because they show humans indistinguishable from us communicating, representing the world they see around them. Now, the exact purpose of these is unknown. Was this art to show where the good hunting grounds were? Was it art to brag about their hunting triumphs? Was it a way just of responding to the world as they perceived it around them? What was important to them? Who knows? But the fact they were able to do that, the fact that they were able to communicate in such a way, I think is fascinating. So, as we see conclusions there written in Sumerian, which is the oldest written language that we have records for, we can see that there is a wealth of evidence, both from body fossils and from trace fossils, of this evolutionary development of hominids, resulting in Homo sapiens, us. What I want to do next lesson is take that a step further and to consider some of the causes of this really very rapid and marked evolutionary change, in particular with brain size, to understand why we've ended up with an evolved ape that dominates the planet. Anyway, that's for another lesson. I'll see you then.